Yeah, sorry about that.
Oh, it's okay.
You have a question?
Yeah. Yes. So, I'm kind of right now. I'm kind of struggle at number 18 and 20 in the homework. I mean, for the homework in chapter 17.
Chapter 17. Okay. Which question is it?
First is 18.
Okay. Can you also give me the page number?
Oh, wait. It's 490. No. 492 on the PDF.
Okay. All right. So 18. Let's see. All right. So what they want you to do is they want to make it so that the original length. Let's see. Yeah, they want you to make it so that the essentially the diameters of both are about the same. Um, and you can actually use essentially the length equation. So that
Uh,
means they're going to start with their own initial length, and then they both are going to have to increase such that they end up with the same final diameter or final length.
oh, okay. So yeah, so like set up an equation like the so let's say the diameter is L, and then the L of the bronze plus the delta L bronze equals the L of iron plus the difference of length in iron.
Yes. And then you could use the expansion equation to figure out, what that common final temperature is.
And Mr. Cloud, are you still there?
Hey, what's up?
Okay. Yes. So for number 18, part A, part A, I think I got 397.57 in Celsius.
No, that doesn't sound right. All right, so you said you got negative 162.9. All right, so that's for
Yeah.
the change in temperature, right?
Yeah.
Okay, so they want to know what the final temperature is.
So should I do like 15 minus 162.89?
Um, no, so it's change is always final minus initial. So we're looking for the final. The initial is 15 degrees. So it'll be the change in the temperature equals final minus the 15.
So is that gonna be negative 147 something?
Yeah, that sounds about right.
Hmm. Yeah, I mean the numbers here are a little complicated. I took me a long time to check everything's are filled in the right spot.
Hmm.
Okay, let me see if
Part B is pretty much the same thing, except they essentially switch the two items.
okay. Oh my gosh. Okay. I will do that later. Let's just um. Okay, so let's just look at 20. So in 2028, there in 28 there was one thing like so I oh Mr. Cloud, can you see number 20 here?
I mean, I'm looking on my own screen. Are you trying to show me yours?
No, no, no.
Oh yeah, no, I see 20.
For 28, I did the step all the way till it's gonna become rho in the parentheses of negative beta times change in t over 1 plus beta times change in t. So I'm not sure. Should I just eliminate this beta times delta t?
Yeah, so the main thing to remember is that beta is a fairly small number, right?
Okay.
It's going to be a number, times 10 to the negative something. And the temperature range, the temperature difference at least, is also going to be fairly small. So that means the denominator that we have is going to be 1 plus a very small number.
We can just kind of eliminate that, regard as
Yeah.
0.
Yeah, we can regard the beta delta t to be roughly 0 compared to the 1 it's being added to. All right, so this is actually very similar to that. There was a question we did in one of the previous classes. I think it was the fractional change in the amplitude for some sort of harmonic oscillator. It's basically the same idea there, where I said before that when you see that word fractional change, that's supposed to be like doing the percent error without the times. Actually, it could be with the times 100%. Um, but fractional change means you're looking for the change in the density divided by the original density.
Changing. Okay. So changing the original. Hmm. So is that just gonna be negative beta times changing t? Because upper and lower rows can be eliminated.
Yep. Yeah,
Oh,
and then you could plug the numbers in.
okay. Negative.
You said 7%.
Yeah, and I mean, sorry, 0.7. Sorry.
Yeah, yeah, yeah.
Okay.
Any other question you want to go over?
Not yet. Is it almost finished?
What?
I mean, is the meeting session almost ending?
Yeah, it's gonna be ending at 8.
Okay, I'm trying to do some more then.
Yeah, no problem.
Pressure mean again. I feel like I saw that somewhere, but I kind of forgot.
Gas pressure?
No, no, gauge, like
Oh,
Gauge.
gauge pressure.
Oh, sorry, yeah, gauge. Sorry.
Gauge pressure is the difference between two different pressures. So, for
Oh,
example, usually it can sometimes mean the amount of pressure above the atmospheric pressure. So, for example, when you fill up your tire and you're measuring the pressure inside, you're typically measuring the gauge pressure because uh, it's not taking into account the fact that the air inside the tire is actually also including atmospheric pressure. Because if you completely empty out the air in the tire,
yeah,
the like the gauge pressure would read or the like whatever you use to measure the pressure in the tire would read 0, but we know that because it's open to the atmosphere, it has to be in balance with atmospheric pressure.
Do you mean like the amount of pressure that's just relatively higher than most atmosphere pressure?
So that's what the gauge that's what gauge pressure is whatever pressure is added on top of. Another example is like if you were to submerge something in water, right?
Yeah.
We in the previous unit we talked about how to find the pressure caused by being under the water, and it was equal to rho gh. But that ignored the fact that the water is also being pushed down by the atmospheric pressure above it. So if we want the actual pressure at some point below the water, it would be the atmospheric pressure plus the water pressure.
Oh,
But because that's not really like who cares about the absolute pressure in some cases, because of the fact that that's what we're experiencing, we want to know how much more pressure it's experiencing. So that's why we talk
so
about the gauge pressure.
gauge pressure is basically how much more than the atmosphere pressure.
Yeah,
Okay.
yeah, and it's important to remember that the ideal gas law, the P in there, is always absolute pressure. It's not gauge pressure.
Okay.
Hey, what's up?
Yeah. Uh, just asking the in the formula PV equals nRT, the R is constant, right?
Mm-hmm. Yeah.
Okay.
Hey, what's up?
Uh, so is the final answer gonna be 94,114 for
Um,
34?
for 34.
Yeah.
Uh, that's supposed to be the volume,
Oh yeah, yeah. I mean the volume.
and you got 90,000.
Yeah, like
No,
I. Okay. Pressure, right?
say that one more time.
So in here, when we're calculating the pressure, we should use 1.013 times 10 to the 5, right? Like instead of 180 m.
Yeah. So I mean, realistically, it all depends on what you're going to be using for R, because R tends to have different values depending on what units you want to use. So
Okay.
technically, I'm pretty sure there's an R term with atmospheres instead, but you might as well convert it into pascals.
Oh, so is the answer gonna be 0.929?
No, that still seems high.
What? Hmm. Something's
Well, what are you using for R?
R is I used it for 8.314
Okay, and the number of moles.
for is 14 moles.
Temperature.
Temperature is 283 K.
And what's the pressure?
Uh, so let me see. So around 35,455.
Are you using gauge pressure instead of the absolute pressure?
Oh, oh yeah. Oh, okay. I see what's wrong. Okay, so I have to do like 1.35 plus 1, right?
Yeah.
Oh, I see what's wrong. Hmm. Oh, I think the time's almost ended.
Hmm.
Okay, yeah. Okay, maybe yeah. Let's just end up here. Yeah. Anyway, thank you for your help today. There's not much questions left anyway. So
All right, no problem.
yeah. Bye, Mr. Claw.
See you later.